All right, this is a video on graphing two variable inequalities, and we'll start with an introduction and then do a couple solved examples. So a two variable inequality is represented on a graph as a half plane. In other words, you have a boundary line that splits the entire Cartesian coordinate plane in two, and then you're shading one side or the other. And additionally, that boundary line could be either a solid line if the points along that line are included in your inequality, or it could be a dashed line if we want to exclude those points. So some things to be thinking about here. We have a linear inequality, and this equation is this inequality is a graph, is an example of one. We have a boundary, which is this line right here. We have a half plane, which is the entirety of this shaded region. And then we have a test point, which really could be any point anywhere that we want to test to see if it's valid. We often pick the origin just because that is an easy point to test, an easy point to throw into our inequality to test to see if it's valid. If the test point is true for our inequality, then we shade the side of the boundary line that includes the test point. So here we can say, we're curious, is 0 less than or equal to negative 2 times 0 plus 3? Is 0 less than or equal to 3? It is. And so that's how we need to shade the side of our boundary line that included 0. Okay, so that's our test point that we're talking about right there. Okay. Let's do a couple examples. So first off, we can graph one in standard form. 2x plus 3y is greater than 6. Did I have a reminder up here? I didn't. That if we have a greater than or a less than symbol, we have a dotted or dashed line. If we have a greater than, equal to, or less than or equal to, we have a solid line. Okay. So let's plot the boundary line first, and then we can shade one side or the other. Okay. So I'm going to go ahead and do that. 2x plus 3y is 6. The way I do that, so in other words, the boundary line is this. 2x plus 3y is equal to 6. The way I do that for standard form is I use the intercept method and I pretend x is 0. And what's y? In this case, y would have to be 2, solving for y. And then I additionally pretend y is 0. And what's x? X would have to be 3. Okay, and we can draw this line in. And I'm going to try to see if my eraser tool here can make this a dashed line. Let's see if it'll work. Nice. Because it's hard to draw a dashed line. Okay, but we want a dashed line because of this greater than symbol is not a greater than or equal to sign. Okay. And let's get rid of some of our work here. All right. Now we have to pick a side to shade. And sometimes you might be thinking, well, it's a greater than sign, let's shade above. Sometimes that works, sometimes it doesn't work. So I think it's always good to plug in a point. So let's pick this test point of 0, 0. And is 2 times 0 plus 3 times 0, is it greater than 6? Is 0 greater than 6? No, it's not. So we're going to shade the side of the boundary line that does not include 0. And let's see if I can do that with this guy right here. You don't have to shade every little bit of it. You just have to make it clear what side you're shading. Okay. And I wanted to give you an example where the test point really matters, and that really happens a lot when we have a lot of negatives and subtractions in here, where it's kind of hard to tell, is it really a greater than, or should we really shade above, or should we shade below? So let's do the same thing here. Let's graph using intercept form, 0 comma something, and then something comma 0. So let's plug in x is 0 first, and so that's going to make that term disappear, and y will be a negative 2. And then separately, let's plug in y is 0. It's going to make that term disappear, and x will be a negative 3. Okay, and again, this is just to graph our boundary line, which we're going to do first. 0, negative 2. Whoops, not that. And then negative 3 comma 0. Okay. So let's graph a line, and once again it needs to be dashed, so I will make sure I dash it carefully. Throw some arrows on. Okay, now I have to pick a side to shade. Is negative 2x minus 3y greater than 6 if x and y are 0? So this is our test point. So let's do our test point over here. So is negative 2 times 0 minus 3 times 0, is that greater than 6? Is 0 greater than 6? Once again, it's not. So we can't shade the point that includes 0. And so once again, we will shade the side of the boundary line that does not include 0. I threw in this example because we have an example of a greater than sign where we're shading below the line. Okay, so don't just think that if it's a greater than sign, you'll shade above the line. Okay, you need to do a test point. We can do an absolute value inequality as well, and I want you to remember our rules for inequality. We have a vertex of negative 1, 3, or excuse me, our rules for absolute value functions. And we have a vertical flip and a stretch that we need to apply as well. So that's a vertical flip and also a stretch of times 2. So let's throw in our boundary line or our boundary function. And with the slope, the stretch is times 2, so we go down 2 over 1 in both directions. And I will draw it in as a solid line first, or a solid ray first. And then I will make it a dashed or a dotted ray. Okay. You might think it's just for aesthetics to dash it, but it's really an important part of the solution to the problem we're doing. So we need to pick a test point, and once again, we will pick 0, 0 as our test point. So is 0 less than negative 2 times the absolute value of 0 plus 1 plus 3? We're seeing if this is a true statement. Is 0 less than negative 2 plus 3? Is 0 less than 1? It is. So we shade the side that includes 0. So that, that's this zone inside our absolute value function, okay? The portion of the plane that includes 0. And lastly, we can go from a graph to an inequality. If we're given a graph, can we get an inequality, okay? And what I can see already is going to be challenging about this is that the line goes through 0, 0, okay? So I'm going to actually end up choosing a test point off the line to sort of in the interior of my green shaded zone to test this, okay? But it looks like we have a vertex already. We have a vertex of 2, negative 1, and we can find a slope here as well. We go up 1 and over 2. So it looks like the slope of that arm is going to be 1/2. So that's a vertical compression with no sort of reflection at all. So let's write it out. We have a y equals 1/2 times the absolute value of x minus the x part of our vertex plus the y part of our vertex k. So we could just say minus 1 right there. That's the boundary function, okay, the solid green line. Let's take a point. I'm going to guess that since we're shading above, that we have a greater than or equal to, and I'm going to check that for sure. Okay, so that's my hypothesis, but let's pick a point, I don't know, how about 1, 2? So this could be my test point. So x is 1, y is 2. So is 2 greater than or equal to 1/2 times the absolute value of 1 minus 2 minus 1? Okay, probably good practice to make your 1s not look like your absolute value bars. That confuses things. So let's simplify this. Is 2 greater than or equal to 1/2? 1 minus 2 is negative 1 times the absolute value of that is positive 1. So then minus the other 1. Is 2 greater than or equal to 1/2 minus 1? It is. Okay, so that is correct that we shade the side above my function, and then it looks like we have a correct solution right in there. Nice, we made it. Good place to stop.